So let's do another one. So we've got moments going on with this. 20 on one side, 21, and then we have a mass unit 1 going 1 distance away to balance. 7 units of mass at 5, 3 units at 10, we need 1 unit of 5. Okay? And the physical version of this is purely moments. That's actually what's happening. So we've got a mass at a distance, or a force at a distance. Yeah. So we measure the distance, how far across, which direction is the force acting in. I was going to talk about perpendiculars until next week. But the idea is, to get this to balance off, we've got to have the same total of product of the amount of mass times its distance, or the force times its distance, going anti-clockwise, as we have going clockwise. And they can be made up by different distances and different amounts of weight. Quick question, as well as putting weights on, how else could I make this balance? Let's go to that one. This one, we're going to say we need to put 70 on that side, 72, we need what on this side?
2 on the right side.
So we could put 2 on there. How else could you make that balance?
Change the distance, right? Instead of changing the mass. You can move the actual pivot, the ruler.
I can't move the pivot. We're talking about this pivot point. But there's a couple of other ways we could go about doing this.
Are we allowed to move the 2 that are already on there?
No, they've got to stay there. Don't think about there just being gravity. What about if I put a balloon with helium in it that produces 1 mass? If I put that on that 2 side, it could lift. That's turning which direction then? So if I'm lifting on this 2, it's now turning clockwise. It's not thinking left and right, it's thinking clockwise, anti-clockwise. Is this force trying to turn it clockwise or anti-clockwise? For them to be balanced, they must equal. So let's go from that one and think about another couple of quick methods. So this one's an investigation one, so I'm going to say this time we're not going to fix it by putting 1 mass in one place. So I've got there. Let's go for. Let's go for that. That. And I've got a mass of 3 I need to put on, I think. I've got to put 3 of these on to balance it. Now there's lots of different ways you might be able to do it. So we've got 16 on this side, plus 5 is 21. That side we've got 14.
You can add 1 onto the 2.
If I add 1 onto the 2.
Not to the 2, sorry, the 7, I mean. The 2, like the times 3.
So I could balance it using that one.
Yeah.
Little balance. But I said I've got 2 masses I want to put on.
2 on the 2 and 1 on the 3 on the right side.
Okay, so we could put 2, 2, and 1, 3. So that's gone together to make 4 plus 3 is 7.
1, 1, 5.
Yeah, 1, 1, 5. And it balances.
8, 1, and then 2 on the left.
How about, right, I was going to say, can we do some sneaky ones? Yeah, so let's put an 8, 2, and 1 there. And then if we actually think about them, on this side we've got 16 anti-clockwise, 5 anti-clockwise, 7 anti-clockwise, 7, 16, 23 anti-clockwise, and going clockwise we've got 14, 22, 23. They balanced. Okay. So that's basically the basics of moments, and that's what we're talking about. So I'm going to do a quick sketch, do a couple of situations, and we'll talk about the missing force needed to balance this situation. So that was my year 9s. Moments turns up as.
When you brake, the car goes like that?
You get that, but this is more general than that. Moments is actually talking about a force acting at right angles. You're right about right angles, Thomas, to its distance. And that is actually the same as torque. So if you talk about the torque of the engine, it's effectively the amount of excess force you can create at the wheels, or at the flywheel, generally when they talk about the engine, but the torque that gets to the wheel is all about the force and how long is the lever it's working with. And that's what we're talking about, is the whole principle of levers working. So it's a turning force times the perpendicular distance from that pivot. And it doesn't matter if you consider it that way. Or if you do it the other way around, it is the perpendicular force times the distance from the pivot. And that's the definition of a moment. It's a moment which can be linked to torque and levers. So the sorts of things we've been talking about is solving relatively straightforward problems. I think all the ones in the first section are to do with these pivots. Got a horizontal line, got a pivot point first there, and I've got a force acting this direction of 3 newtons, pushing up 3 units away, and I've got a force acting that way, 2 newtons, and I would like to know what force do I need to act here at 2.5, yeah. I want to know what force needs to act there. So I've just flipped it over. Could quite easily just flip the arrows over and it would still give me the same situation. So, thing to consider is what happens anti-clockwise on one side, and for it to balance and be in equilibrium. Some good exam word, equilibrium, they like it. Okay. Anti-clockwise, force times distances. I'm going to use R, they sometimes use S, I think, in the books. And clockwise, forces times distance. And they should balance. So looking anti-clockwise first, let's put in this one. So anti-clockwise, we've got 3 newtons by 3 meters. 3 newtons pushing up. Clockwise, sorry, yeah, it is. Okay, let's go for the 2 newtons acting that way. 2 newtons times distance of 2 meters.
Oh, that's given?
Yeah, that was given, there's 2 there. Okay. Yeah, we want to know what force is acting 5 meters away on that side. We could put it in here, so let's assume this is also acting anti-clockwise. So we're going to add to that the force acting at 5 meters. Again, as long as the units are consistent throughout, you don't need to change between kilograms, newtons, meters and centimeters. Just make sure you've got a consistent set of values. It's the scaling of them that matter. Clockwise, we've got 3 newtons by 3 meters. The alternative way of writing this is to say all the clockwise ones you say are positive, all the anti-clockwise ones you probably say are positive. So it matches what we normally do with trigonometry. Clockwise and negative. Just as easy to say that they must be equal. So stick our values in. We've got 4 plus 5f equals 9. So 5f must equal 5 newtons. So the force pushing up on this side is 1 newton. Okay, and we did that by just choosing what happened. What if this force had been negative?
It's going to another direction.
Yeah, it would have flipped its direction. And in this case, it would have been clockwise goes to oh, sorry, anti-clockwise goes to a clockwise force. Okay. So it's about setting up that equation. That's all the first part of moments is to do with. The further bits of moments is to do with using 2 points that could be pivots. And you consider the extremes of, if this one's a pivot, what force would be in the other one? That's how you solve nearly all the moment problems, with the exception of the one about we've got forces acting at angles, which is next week. Yeah, next week. I'll give you just one quick one on this. Where did I put the book? There. Let's make sure I've done some of the horrible one. Chapter 8, section 1. I'm not even sure they do the being perpendicular. I'm sure it used to be in here.
I think it is, yeah, resultant moments. They show the angle.
Oh, that's the tilting they've gone on to it afterwards. They've broken it down to quite a bit. Right, so... yeah, because they start in a slightly different place. Let's go to that one. Pivots. There we go. So we're looking at exercise 8B-ish today.
What about 8A with the angles?
The bit with the angles we'll do on Monday.
Oh,
Yeah. Because they don't tend to mix that with the pivots on bars.
oh.
And it adds complexity before, I think it'd be easier for us to deal with things where the theory gets dealt with, and then let's put in funny angles. What have they got here? What's their question? So the force is acting on rod, calculate the force. Okay, this next one is, there is going to be a result. So they're asking what is the result in moment in this question. So it's effectively asking the same as what I asked here. The resulting moment here was this 5 Newton meters. There, that's the resulting moment that we had to correct for. So in this one, we've got 5 newtons on one side, about a pivot that's got 1 meter and a force going that way, and the 3 meters on that, 3 newtons on that side. 1 meter, 1 meter, and 2 meters.
Isn't the unit Newton meters?
Yeah.
So,
I said here what was the force needed to balance.
okay.
Yeah, because we had a force 5 meters away. Yeah, that's why when I looked at this, I went, let's do what is the resulting moment. So, I'm sorry. First of all, let's do anti-clockwise. Forces acting anti-clockwise are the 4 newtons at 1 meter. That one. So I'm going to tick off to say I've done it. We've also got anti-clockwise 3 newtons at 1 meter.
When it says calculate the moment, do we need to show the direction?
Yeah, we've got to include what direction.
Like,
So
do we draw like an up arrow, down arrow?
Or do we say clockwise?
clockwise, anti-clockwise. And let's build it up from the next part. So clockwise we're going to say is now negative. So positive is anti-clockwise, clockwise is negative. I've got acting clockwise, 5 newtons, how far away?
3 meters.
3 meters, don't forget 2 plus 1. So it's about the point P. Stick the numbers in and that gives us a resulting moment. They use M for this, or don't they even put a note in? Okay, I'm going to call it the moment about P. And like Anna said, the units of moment, because that's force times distance, is Newton meters. Stick the numbers together. 4 plus 3 minus 15. And the resulting moment is 8 Newton meters minus 8 Newton meters. What's the description for that one then?
What is the positive that it shows?
Positive we said was anti-clockwise.
So it's
Yeah,
clockwise.
so it's clockwise.
Yeah, so the negative is clockwise.
So we can either say 8 clockwise or -8 anti-clockwise.
Yeah, if you said -8 anti-clockwise, if you just give it as -8 without interpreting clockwise or anti-clockwise, you're on shaky ground. Yeah, so you do need in your answer the direction and the moment when you're talking about moments. If it's one of these force questions, you don't always have to do that. So you work out the force and say if it's pointing up or down.